Today we're going to look at section 3, which deals with the properties of both exponents and of logarithms. First, the properties of exponents are what we're going to look at. These you should recall when you have x to the 0 power, that is equal to 1. Anytime you have a negative exponent, that means it's the reciprocal, 1 over x to the n. If you have x to the a times x to the b when you're multiplying and you have exponents with the same bases, then you keep the base the same and you add the exponents. Same thing happens when you're dividing. If the bases are the same and you have exponents, you keep the base and you subtract the exponents. And finally, when you have a power to a power, then you leave the base alone and you multiply the two exponents. Like I said, those are the basic properties of exponents that you should recall. The logarithms all have a similar property to each one of these. The first one would be when you have log of some base of 1. That is equal to 0, because it is saying b to what power is 1, and it has to be 0. It relates to this property. The second one we'll discuss later, as it has a property later on. So then we'll move on to x to the a times x to the b, which equals x to the a plus b. In the properties of exponents, or in the properties of logarithms, we have log base b of x times y, similar to this property here. They are related. And in the property of logarithms, when you have log of some base and you're going to multiply two things together, just like here, then you can add by breaking it apart. Log base b of x plus log base b of y. Now the same thing could happen if the base were e and you saw ln of xy. That equals ln of x plus ln of y. It doesn't matter what the base is, but if you're multiplying two things together, you can break it apart and add. Similarly, you can, if you're given log base b of x plus log base b of y, you can take that and combine it and multiply the x and the y together. Properties of logarithms number 2, log base b of x divided by y. That one would relate to this property here in exponents. Or in exponents, when you're dividing, you subtract. So in logarithms, it's the same thing. Take log base b of x minus log base b of y. Or if you're going to look at it with a natural log, ln of x over y equals ln of x minus ln of y. Third property of logarithms for today would be similar to this property of exponents, where you have x to the a times b, or x to the a to the b power, it equals x to the a times b. So in this case, when you have log base b of x to some exponent r, or whatever the exponent is, the r gets pushed to the front of it, and then you are multiplying it by the log base b of x. And again, if you see it as a natural log, ln of x to the r is equal to r times ln of x. And so those are the three main properties of logarithms that you're going to be seeing today. Like I said, they relate to the properties of exponents. The next property of logarithms is the change of base property. And in the change of base property, if you have some logarithm of a base with an a here, you can change the base to any base that you would like, and then write log base c of a over log base c of b. Now the reason there is this property is, like I said, you can change it to any base, but the two that you would want to use the most would be a base of 10, so you would get log base a, or log of a over log of b, which you could also then use natural log, so ln of a over ln of b. And either way, you will get the same answer. Now, with some examples of that, with this first one, log base 2 of 4, this is saying 2 to what power is equal to 4? So this one you should just know it is 2. So log base 2 of 4 is 2. If for some reason you were having a mental block and could not figure that out, you can always use your change of base property, and you would say log of 4 divided by log of 2, or ln of 4 divided by ln of 2. And either way, you will get 2. Now I would hope you'd never have to do that with something like this, but it can happen. So now our second example, log base 2 of 5 is saying 2 to what power is equal to 5. Now this one we can't really figure out in our head, so we would have to go to our change of base property and say log of 5 divided by log of 2. And that would get you approximately 2.322. Once again, for this one, you could also do ln of ln, ln of 5 divided by ln of 2. That was interesting. And you would get the same answer of 2.322. Finally then, log base 8 of 3. Here you would have log of 3 divided by log of 8, or ln of 3 divided by ln of 8, which is approximately equal to 0.528. As far as rounding is concerned, probably going to at least 3 places past the decimal would be an appropriate amount, depending on what the value is that you're going to get. So that's using the change of base property. Now, using these other properties, you're going to be asked to do some things like simplify expressions. So let's take a look at a few. This first expression is log base 5 of 2x to the third y. And you would be asked to expand this expression. So first, we can use this property right here to break this up the 2 and the x, and the x and the y. So then you would have log base 5 of 2 plus log base 5 of x to the third plus log base 5 of y. And then we can use the third property to simplify this middle expression, log base 5 of x to the third. The 3 can get pushed to the front of this log base 5, so our final answer would be log base 5 of 2 plus 3 times log base 5 of x plus log base 5 of y. In our second example, we have natural log of x to the fourth over 2y. So first, using the second property, we can take this division sign and turn it into subtraction. So we would have ln of x to the fourth minus ln of 2y. Then the second thing we can do is take ln x to the fourth, and the 4 can get pushed to the front to get 4 ln of x minus. And now here you have a couple of different options when you do this part. Because we can take and break this apart, because it's 2y, using the first property, you can put minus, and then because we have both of these things, it would be in parentheses ln of 2 plus ln of y. The other way that you could write that, since it's subtraction of both of those two things, you could write minus ln of 2 and minus ln of y. Either way, these mean the same thing. You're dividing by both 2 and by y. In our third example here, we are going to condense an expression. So we have log base 3 of 7 plus 9 times log base 3 of x minus 2 times log base 3 of y plus log base 3 of z. So when we're going to condense, we need to get this down to 1 log base 3. So here we have a 7 plus an x. So that would be 7 times x. This 9 becomes the exponent for x. Now it says minus 2 times log base 3 of y. Subtraction means you divide, so we have to divide by y, and the 2 becomes its exponent. And because this then says plus log base 3 of z, it's times, so we put a times z, which then you can simplify this to log base 3 of 7x to the 9th z over y squared. If there were parentheses here and here, now since we are subtracting both of these two things, it would change your answer ever so slightly, because now the z would also be in the denominator, so you would get an answer of log base 3 of 7x to the 9th over y squared z. Because in this case, when it's in parentheses, it means both things are being divided. Whereas in the original one, this is divided, then this is multiplied. And so that's why it's written like this first, and then you can multiply things and get that. And that concludes this lesson on section 3.3.